Testing, testing. Welcome back. I'm Michael Wickerson, working at the MGSM International Competition to put together some Grasshopper scripts for people that are interested in Rhino but want to be kind of handed a lot of what I refer to the master scripts broken down into about 60 sections with multiple scripts. And I'm still in maths, and I'm going to pack in polynomial scripts, trig, and utilities in here fairly quickly. And we do have a few geometries being produced here, which may be understandable or not. I do like to keep my standard viewport here. I like to keep zoom extends all, and maybe zoom into what I'm looking at. What I have here, I'll take it so we're only looking at what's actually being selected. In the maths polynomial scripts, trig, and utilities section, consider using the expression nodes rather than the function node. I put that in here because I do like using the expression node, because you can see what's going into it a little different than putting in paneling tools, and you can update it. You can work with calculus and limits and algebra very quickly by using this. So that's just a recommendation. Set your variables to x and y. That's the biggest thing in this node as you bring it down in. I'll just bring a sample node in. It comes in as variable x and variable y. Nothing will work unless you call your variables within here variable x and y. So you just have to do a first click, and this will get you in practice for actually getting into the Python node, the GH Python node, and certainly the C# node. So just change those variables, and then you're up and running. What other advice do I give you on those? And I'm kind of moving beyond the polynomials here. I think because I put those into the last script, I may use them again here. Possibly I should be calling this script instead of polynomials, but it's everything basically. Play with the operators, polynomials, to explore domains and complex number sets, which can be very exciting as well. Complex numbers will move you off of the real line and into theta, and the ability to move within angles to define points. And it can be very wonderful when you want to wrap your head around what's actually happening geometrically. And I think there is a nice big master script coming tied to complex numbers after dealing with linear algebra and single variable calculus. So we'll see what I end up putting together on a more advanced level. Graphs and 2D geometries in top view. So set this one over to top view. See what you have and see how this starts. When we go up into the z direction, I want you to realize that we're actually just producing points. And there we are. We're basically just producing points without the z coordinate, and we're putting a polyline between them. Now this defaults and jumps over here because they're not separated on one side to the other. So sometimes the geometry doesn't behave like what actually will be graphed if you're in your math classes. But what's nice is I use think about what a range is compared to the domain. Domain is where you're going on the x-axis from -4 to 4, and you can play off of this and change it. I have a series of steps for kind of making a nice finesse and lots of points for the curves so they behave nicely when I interpolate or draw a line through them. And the range is where they go in the y-axis. So I literally went back to my good old math equations. I put a couple of variables in here, a and b, and I wrote two equations, one of which using the expression node, and actually both using the expression node. One is the square root of a times x squared minus b, and this is where a lot of this led into our conic forms in my discussions I was doing with David Christev on the Dominion. Very excited about where that's going. And then I have an a times x squared minus b over here. And I throw the square root through after the fact. So it's just something that you start packing your scripting code into. You can use the evaluation tool with your variables x and y's and then put in the expression in. But like I said, I prefer the expression node over that. And if you're actually following my videos, you'll find I use that quite often. So just a nice little example of taking those points, putting a polyline through it. You could definitely take those values and put those into the y component and see what geometries are built. And you see they're a little lower here because I didn't add them. Let's see what happens. For that square root value, took it as a full value into the y, so I had that lifting up. This one will go and not come all the way down to the bottom. This one actually does the square root after it and gets a lot closer to the y equaling 0 on the real line. So that could actually be pretty exciting. And so follow that. Follow the math. See what you want to tuck into the expression node, and you'll find that that plays into actually scripting and writing into your Python and C# nodes. Lots of examples with domains and ranges. Go back in here and grab the points. Well, I obviously can have that graph start a little farther this way, have start a little farther that way. If you want to see the visualization of the curve, you can see that as well coming in from the right and out from the right. And there's that little bit of jumping and articulation here. I actually find this pretty interesting. You go up here and then you're getting this really nice curve from 4. You see how that kind of wiggles down, and it's doing a little do-si-do in jumping because we're actually dealing in a certain amount of polylines between these points. But the more points we put in here, the more finesse we get. And you can take that up, crank that up to as high a number as you want, and it still will run very quickly. Keep in mind that when you're using an expression node and a lot of nodes in Grasshopper, things are going to slow down compared to using the scripting nodes components. Anyway, I'll leave that and I'll go into the next one. Trigonometry leads to some of the most beautiful curves and tangent lines. So the same thing, I have a range running. I have a domain that's running from -10 to 10. As a number, I have finesse of 100 steps between it and a range that's jumping up in the sine curve in the z-axis. And as soon as I see I'm using z, I'm going to want to go over to my perspective view. And they basically have put a sine and cosine amplification that I have a really nice helix that I have pretty good control. And this is pretty common script that you'd see written in many, many forms online through cosine and sine with a multiplier and an interpolated curve, and you get some very nice curves. And this was some of the first development I did for ARA jewelers to do this. And then what I do is I realize, well, what could I do with that? Let's play off of a little bit of these utility functions and these magic numbers, which really are pi and golden ratio and radians and degrees, how I can play with those. So I've taken a center axis point vector actually to rotate around. I've done a revolve around the 0 point. What ends up happening as I roll an angle of pi from 0 to 2 pi, starting to manipulate that and think about what that actually does. And you start seeing your nodes as actually transformation expressions. And you might see them as matrix transformations as well. Depends how much in math you're actually looking at. If I rotate 3D and take it through radians, I'll have my radians set that it's running through the degrees from 0 to 360, which would do a full 2 pi rotation. And I can always take my radians from 0 to 2 pi and roll that through my degrees. I would prefer, if you follow my videos, that you start making a jump to radians. It makes much more sense to me. And there are some options in here, jumping in and changing from degrees to radians in the rotation nodes. If you are going to start scripting and take an interest in that, you'll probably want to start learning how to script what's behind the scenes in a lot of these basic transformation nodes and let's say interpolate curve or a point generator construct curve node. So these are just playful little scripts that I'm using to get an understanding of the math tabs, and I'm providing them all for you so you don't have to build them from scratch. You can jump into the number sliders. One thing I like doing is considering sharpening and smoothing data with utility nodes. Now, what do I mean by that? I like these that I can reset my data, and I can move these and record data. You can see it takes in multiple data, and I have this minimum and maximum functions that will grab the result of those numbers. And I've just made those both run as a data recorder. If I turn this one on, I start sliding through here, start to grab data in degrees, and that will output the same thing right here into the nearest, the floor, and the ceiling. So I'm rounding that number, and it's staying around 14 right here because the data recorder was off. So let me turn it on, and there you go. It's starting to round those up and put them. What's nice is I get into the average and average and average of what I'm looking at within those numbers, and I start to use the data container to see what was being pulled out. So I'm playing around pretty loosely with what's happening within these average, and I'm creating my list using a data recorder. It's a technique I've been using lately, and I find it pretty interesting. This can get pretty confusing, but then here we go. We have a bunch of little wonderful abilities to jump in here and play with data. And this is probably prior to any data analysis for machine learning or things you might be looking into. But there's a nice component for blurring numbers. There's a nice component for interpolating data, not just interpolating lines and curves, and smoothing numbers and truncating numbers. And I would say play with that and play with these factors. And if they have a very small float decimal, you might want to check what that range is from. It tells you right in there that it runs from 0 to 1. So you can play with that to truncate data, to smooth data. The parameter setting here between the data will grab where you want to go. So I'm set at 0.39. I can take that and move that in each direction from kind of the domain of what's being used. And it has a pull and pull strength on here. This one will say go from 0 is none and 1 is full. So you can put that through a number slider from 0 to 1 as well. There is a count to iterations. Be careful on iterations because when you start to climb in numbers pretty high, it can get a little complex and can slow your program down. But there's a bunch of utilities in maths that are worth exploring to see how they drive your geometry differently. Now, getting into the chaotic area of this and ending with it without going into full detail, because this is not possible in the length of this course, probably want to spend a little while jumping into it, is programming within the GH-Python node, or the VBScript node, or the C# node, will lead to scripting in Visual Studio Code, I believe, or even machine learning beyond the Lunchbox plugin nodes, because there is actually a Lunchbox component that gets into machine learning, and all of these are kind of composed for you. You're going to find the Python nodes really support Ladybug and a lot of optimization, environmental studies. They're all written kind of in a GH-Python node, I believe, and they're all packaged in there. All Python libraries can be brought into Grasshopper through the GH-Python remote plugin, which I've actually removed. I was using it, but because I'm dealing more with Visual Studio, it just seems a little strange to go back and in the maths pull out that extra node. And I had it in use here for a while, but I'm not going to jump into it. If you want to go in, it's a pretty complex operation, and I have a whole video series on the GH-Python one-liner, and I use the GH-Python remote node throughout that entire series. And that's a much longer project. It took me about a month this summer to compile all that. Here are your nodes. They work kind of the same to jump in. You have to go in and set all your variables, not just whether they're an item, list, or tree access, but you always have to get in there and do the type and find out what they are. Even though Python's a little less type sensitive than C, you are going to have to specify those for Grasshopper, those types of what you're bringing in. So jumping into it, I have a few examples, and they're customized nodes, which I make some of my students get around playing with and making. But GH-Python, here's one here, and as I double click on it, it's not compiled from Visual Script, and it's not packaged, and it's not hidden, and it's not passworded. It actually has 3 inputs that I can hover over, and you'll see that that one is asking for an integer. This one's asking for an integer. This one's asking for an integer, and it gives me a data output, which this is a Wickerson Studio GH loop. So if I double click on it, you'll see the script that pops up. And it's been used to working in Rhino and actually going into the tools and working within the the Python script. Let me get this out of the way. Oh boy, double clicking too much. If you're used to going into the tools and writing in Rhino script and getting in there and editing within that, or Python script, this will be pretty similar. A lot of things open up for you. The script is fairly simple. You can see that I threw it through an iteration for I and X, print I, and then I'll print a blank in between that. For I in range X, Y, I'll print I, and for print, and then I print space, and for I in range, I'll print that. So I basically have made my own node that's number driven. I'll start a number slider here, and this gets a little confusing for those new to it. I'm not going to go into too much detail, but a very simple script to get this one up and running. That's how it goes from red. I've got my integers in here, and the output being generated. You always want to see what it ended up doing. The output should be up here as a print function. It's going to print the spaces in between the data that I had. Now I set A to nothing in the script, so there's nothing coming out of A. It's null. So really, it's just pushing it to an output. It's a great way to debug things and have a look and get your nose into scripting and coding if it becomes of interest. But I'm going to leave all of this kind of blank and off. I provided many examples. Make sure you close the files. There's lots of tricks to learning this. And here's a one-liner lambdas function that I wrote, which is asking for a GH.doc object when geometry is brought in. What have I actually asked for within here? It's a lambda function simply giving me X. I will add X to Y, and I would output Z. And there's another example of running that through and getting that script up and running. This one runs on on list comprehension because there's no inputs required, and it's hard-coded in as a script to say for key and value in persons of interest item numbers. And I have my data up here because I was thinking of some of the machine learning chapter. I'm simply going to say if the value is greater than 75, we're going to append a list with key values in favorites, and then we're going to output that in A. So this function runs, and it's hard-coded, so you have to get into the script, and you're finding out which ones are 75 and above, and that's what's actually being printed, 75 equal or above. So it gets more and more complex as you go. Here's one that plays off of decision tree machine learning. And like I said, it gets hard pretty fast, and then calculating a power set is hard-coded in. I'll let you have a look. Very similarly, make sure you close those. You may want to go in and check out what's happening in the C components. And I think you can, this all leads to creating your own plugins, and I'll show you examples of that. And I actually have 2 at the beginning of the stages of what I was doing with Daniel Christev. We've actually made this plugin to Dominion. I would encourage you all to download it. It's free on Food for Rhino, and it's a conic solver. and it deals with some wonderful tools for constructing parabolas and hyperbolas. Here are a few examples of those. And the icons, I'll just let you know, they were fabricated by the icons themselves, and they were made in their own bitmaps through Aviary plugin. And if you can wrap your head around it, you can figure out how to do it in Rhino in many, many forms. Going back a little bit, this is just a Boolean union of two breps. You bring in your two breps here. There's a tolerance between them, and it'll output the Boolean in them. And that script uses Rhino Common language. I don't think it uses Rhino script. I think I'm in Rhino Common. It uses a lot of libraries throughout it. But if I jump down to really what's happening, it's a pretty simple script. It basically uses the language of making an array, and union brep is brep using the dot tools to create Boolean union between breps with a tolerance, and then output that Boolean breps. So a lot of this you can end up writing in, and you start to realize that this command line in Rhino has been running a lot of the scripts. And as you get closer to C and compiling and bringing this out into these type of nodes, which are impossible to click in and see what's going on, but you can right-click on these and see the help. And Daniel Kristev has packaged all of these in with the information of how you can go deeper into this. So very excited. This is kind of where Grasshopper has led me. I don't expect anybody to jump right into this off the bat. And there's a few examples. Just double-click and get your nose in C#, and you'll start to realize that this vertical script that's running here is very similar, and you'll adjust your eyes to it. I don't like that this shrinks down like that. It does that, and it doesn't close, and you can close that file. You'll find that these horizontal node scripts, which are slower, that you're writing left to right, start to become these vertical text scripts that you're writing in the C and Python and maybe VB script. In the end, you want to get to this stage, and I've had a partner with a backend developer to pull everything in through Visual Script Studio, but I can kind of show and communicate through my visual interest in Grasshopper. So that's a lot in 16 and a half minutes. Probably one of the most exciting things to get around and play with, but like I said, finishing up these math nodes, if you know 60% of what's going on in the math sets and vector nodes, you're going to have an easy time slipping to all the rest of the nodes and starting to understand what's going on in all of these plugins like Pufferfish and Lunchbox. I got a bunch of robotic plugins here as well, Kuka and ABB Robotics. But you have to acclimate yourself to this, and you'll find as you go deeper into the logic and understanding it, you're going to make neater and neater and neater scripts. And you might move away from this param tool I talked about earlier of clustering and packing all this data into clusters, which is used very well by a place, AJ and ARA Jewelers is what it started as. But it does speed up when you start to deal this way, and you can start operating through Visual Script Studio and GitHub and things like that, which are a little quicker out there in Microsoft to see what's happening. All right, well, thank you very much for watching, and we will continue jumping into sets, which is very interesting, starts pretty visually simple and sensible, and logically goes off into some pretty tricky things with offsets and masks and path mappers, but hopefully you can start to wrap your head around that. Thanks for watching.